Exercise 1. In this exercise, we're going to take a look at how to, first of all, create a simple paperclip inside the SolidWorks 2016 software. Once we've completed the paperclip, and by the way, this is a jumbo size paperclip, by the way, it's very large. We're going to go ahead and run an analysis as if you were pulling it, the edge off right here and pulling it away. And we're going to take a look at elastic to plastic and also yield. So let's begin. First of all, we're going to go ahead and draw what you see there. So let's begin that. That's I'm going to go to a new part file, and you could go to File, New, or else go to the little white sheet of paper up there, hit Part, and hit OK. You have your pull-down menus up at the top if you clip them in. If you don't see your pull-down menus, you have to hit this little arrow over here right next to SolidWorks, and then you could hit that little thumbtack and tack it in. And what we're looking to do is we're going to go ahead and not run the full-blown simulation here. In fact, I'm going to turn off SolidWorks simulation. Not everyone has SolidWorks simulation. It's an additional add-on. But if you have any sort of license of SolidWorks, you could go to Evaluate, and it comes with Simulation Express Analysis Wizard, which basically is the light version of the software, and it comes with all versions of SolidWorks, so everyone should have it. Oops, oh, it's going to wait for me to actually model first, so we'll go back to that. Anyhow, let's begin. On the front plane, if you click on it in the feature tree on the left here, this is, by the way, the feature tree, you'll get this little quick launch, which is Sketch. If you move your pointer away, it disappears. So in that case, just go up here to the Sketch tab and click on the Sketch button. By the way, if you hit the little arrow underneath, you'll see Sketch, 3D Sketch, 3D Sketch on plane. We are just doing Sketch. Now let's take the line tool. It's right up here. If you hit the little arrow to the right of line, by the way, you'll see midpoint line and center line. We're just going with the basic line. Now go ahead and click on this origin. The origin is your zero marker in space. You'll know that you clicked on it or you're about to activate it when you see the orange dot. Then you could go ahead and drag across and make this about 2 inches in length. Now normally we would use the tangent arc tool, which is up here, but we're not going to use that. Instead, I'm going to show you a little trick. With your pointer, you'll notice that you have this chain that started. If you just move the pointer back to that last point there, and then don't click, by the way, you're just hovering over it. Move now to the left and up, and you'll see it will automatically create a tangent arc. Now you could go ahead and click again. Drag this across maybe about 3 inches, and you see those inference lines. That's indicating that I have it horizontal. I'm going to click again. Now I'm going to do the same trick. Chain away and then move back. Just hover over it and then move to the right and down. And notice I'm getting A is equal to 180 degrees. Make sure you get that. I should have told you that the last one too. But go ahead and click. Drag across, and this is going to go maybe 4 inches. And click, and then do the same thing again. Move back to the start. Glide up and around. And a little bit higher. A should be about 180, and your radius, it should just be larger than the other two. So you're really just making it look like a paperclip. And then finally, end at the same point where you began, just higher up, like in this case. Click, and now you could hit escape. Now we're going to put the dimensions in that we saw on that print. So it's we have the 2 inches, 3 inches, and 1.25, 4 for the radius, 5 and 6. So we can put those radiuses in first. So go to Smart Dimension up here, and the smallest one is 0.4. Click on the actual arc, and then move your pointer out here and click 0.4. You don't have to type 0.400, just type in 0.4, hit enter. The next one, this one, click, drag it down, click to drop it again, 0.5, enter. And this one, click, drag it out, click, 0.6, enter. Okay, so the next thing that we need to do, let's go back and take a look there. We have the 2 inch line right here. Just click on this, drag that down, make it 2. Now you could click on the origin and click on this arc. It will automatically dimension to that center point of that arc, and that is supposed to be 3. And just make sure you type in 3 there. Oh, it is 3. Okay, just didn't update. Okay, and then the one over here, I forgot what that was, 1.25. So from this point to this arc, notice it dimensions to the center, 1.25. And now we have our layout of our paperclip. Now if you're wondering how I'm rotating, you can either use the arrow keys on your keyboard, rotates in 15-degree increments, or hold the middle mouse button down. That middle mouse button is your scroll wheel. Don't actually scroll it. If you scroll it, it zooms in and out. You could try that too. But if you just hold the button down and now move your mouse left, right, up and down, push it down like it's a button. Hold it, and then move right, left, up and down with your mouse. Oh, one last thing here. You'll notice there's this little blue dot. It's under Define. I'm going to hit Escape on my keyboard. That gets me out of whatever tool I might be in. I'm just going to select that endpoint. I release it. Now I hold the Control button for the second selection. Click on the origin down here, that red origin when it turns orange, and make that vertical. On the left here, you'll see Add Relations. That's vertical. We just forced it to be vertical to the other one. So now we could go ahead and go up to the top here, and you'll find the traffic signal. It looks like it's called the Rebuild button. Go ahead and hit that. That exits you out of the sketch. Okay, it should turn gray if you rotate it. That means you're no longer editing that sketch. If you wanted to edit that sketch, you could just simply double click on a thin gray line and it should activate it, or you could right click over here and there's Edit Sketch. It's a nice thing about SolidWorks. You always go back and edit things. Okay, now what we're going to do is we're going to select the right plane. The right plane just so happens to be at the end there. And remember the quick launch? Go ahead and try for the quick launch this time. If you don't get it, you go up to Sketch and Sketch 2. Either one's fine. Now, take the circle tool and at that origin, drag out a small circle. Let's take a look at the diameter of that. 0.175. So go to Smart Dimension, click on it, 0.175. And now hit the Rebuild button again up at the top, or Control B as in boy. Okay, now we're going to go ahead and sweep. So if you go to the Features tool, the Features tool are the 3D tools. Click on that and find the Swept Boss Base. Click, and look at this. Over here on the left, the blue box is always what it's looking for input. So we could select our circle for the profile. Now it automatically moved down to the next box below here. Go ahead and select the line. And you'll hit the right mouse button, or you could hit the green check mark in the upper right or upper left. And now you should have your paperclip. Let's go ahead and select the material. On the far left, under Material, right-click, and you'll see Edit Material. There's a library of materials you could choose from. We're not going to go with steel because this is a heavy-duty paperclip. We don't want to put that much force on it. We'll make it out of a fun material. How about let's go with aluminum alloys. Hit the little arrow to the right of it, and it'll pull down. Remember, you can always scroll down. You'll find aluminum alloys. You can see there's a whole variety of different aluminum alloys. We're going to go with like a very weak one, 1060 alloy. Once you click on it over here, you'll see English IPS. Once you change that, hit the little arrow to the right of it, change it to MPa, which stands for megapascals. It's more the SI unit system. So what you can see here, you'll see the yield strength. That's what we're looking for in tinsel. The yield strength is essentially when something bends and it passes that yield strength barrier and it no longer bends back into place. Anything below it is called elastic deformation, meaning it'll snap back. Anything past that is called plastic deformation, and it no longer snaps back. It may not break, but we still might consider it failure because once something is bent, it may no longer be of any use to us. So we're going to try to see what this does on here. So go ahead and make sure you select that and hit Apply. And then you could hit Close. All right, you'll see that the actual part may adopt some of the colors or characteristics visually of whatever material you select. Up here, you have the ability to change it to a plain white background or something if it's easier to see. The 3-point faded looks pretty good here. Also, if you hit this little arrow, you'll see Real View Graphics. If it's grayed out, that just means you might have a non-professional graphics card. Professional graphics cards would include the NVIDIA Quadro series or the ATI/AMD Fire Pro series. Those typically have the ability to turn these reflective characteristics on, metals and such. Okay, but if you just have a gaming card like a GeForce, that's fine too. It's just that you won't get these characteristics. It still works though, in terms of when you do a photo rendering later. Okay, from here now we're going to go ahead and go back to Evaluate, the tab, and go to Simulation Express Analysis Wizard. Now over on the right here, this is the light version if you recall. First of all, if we want to get megapascals, there's a couple things we have to do. Right now it's set to IPS. We're going to get the old imperial units of pounds or PSI. Let's change that. Hit the little arrow there, and let's go with mmgs, millimeters grams second. Also, for some odd reason, you always have to click on the options. It seems as though even though it's set to SI here, it doesn't always follow that. So make sure it's on SI and always check the option. Okay, now we just hit next. The first thing you'll notice at the top of the list, it actually has a checklist for us, the fixtures it's looking for. So this fixture, first of all, we're going to click on Add a Fixture. And then let's imagine we're holding it from right about there. Let's say we lock it in with our finger. We're holding that there. We could do both, but it's kind of cool when you see that we don't do both. We want to see the reaction of the whole situation here. So imagine we're holding that little area between our fingernails. Kind of hold it. Okay, that's the fixture. Hit the green check mark in the upper left there. Now we're going to hit next. You could add additional fixtures, but that's good enough for right now. Hit next. Now, with the light version here, Simulation Express, you get two options, add a force or add a pressure. That's pretty much it. When you get the full-blown version of the SolidWorks simulation, you have vibration, drop testing, linear, nonlinear, there's thermal, bunch of different things that you could test for. We're just going to go with add a force. Okay, so as far as adding a force, let's imagine we click on this little end here with we grab with our fingernail, we kind of pull it from the top there. Pull it down. I know if that got stuck under there, that hurt. But anyway, make sure over here on the left, those of you who are not who are in the United States, you're probably more used to dealing with IPS or English, so the pounds that you would apply to something. And let's figure that remember this is a jumbo paper clip. We will put let's just put 5 pounds of force. Go ahead and hit the green check mark, and now you should see these looks like little Christmas trees and little arrows there. So we're going to go ahead and now hit next over here on the right. And it took our alloy. So if it doesn't, you could always right here change material and apply a different material at any time. Let's just hit next. Okay, let's go ahead and hit run simulation. And it goes through its process. And now we can see it actually bending. Now don't worry, there's a interference there. I wanted to show you some of the unusual effects you get here. Now be aware that this isn't exactly 100% how it might. It's the direction or vectors it would bend in, but not necessarily exactly how far it's going to bend. That's another option that I'm going to show you in here, that you can actually get exactly how far, like, oh, it bent a ½ inch or whatever. But in this case, we're going to go ahead and hit, does the part deform as you expected? Yes. Okay, the first thing is you have the show factor of safety. Factor of safety is a calculation based on safety, essentially. For example, aircraft or aerospace equipment might be tested at 1.5. That's because they have to be lightweight and have the characteristics so they could fly or things like that. Versus automotive industry might use 3.0 for their factor of safety. So in this case, we'll go with 3. Okay, and now when you hit enter, it should update, and you'll see in red. This is pretty much a binary result. What's in red is where you're seeing it's not following, it's beyond your factor of safety. What's blue is within the factor of safety. But just because it's, you can see here, unfortunately, this light version, you can't cut through the part, and quite often, a lot of this is just surface deformation, not internal. So because we can't cut through it, what you do is you look for the marbleization of the colors. And if it's marble, there's very thin elements, you're usually pretty safe that you're within the limits, okay? But that's up to interpretation. So I'm not remember, there's liability involved here. I'm not giving any personal opinion on that one. But anyhow, so moving along. Now let's go take a look at the shown von Mises. And as we can see here, it gives it to us in MPa. What we're looking at is this gives us a more detailed view. It's not binary like the factor of safety is. But here we have the yield strength in 2.7. Remember, we had it, the decimal place was just moved over a bit. It was 27.57. But you could just do the calculation in your head. This is because it's scientific notation. It's not the easiest thing in this light version to switch it to floating point, but if you could do this in your head, you're usually fine. Anyhow, in the full-blown version, you can change it, so it's a little bit easier to read for those of us who don't always read scientific notation. Anyhow, as we can see, the red arrow, that's our yield strength. That's where we start to see yield. So if we were looking at a chart, everything underneath this is elastic deformation. Any of these colors, blue to aquamarine, means that when you release it, it's going to snap back to its original position. However, anything above that, in these colors, you are pulling it and it's going past its limits. So it's going plastic at that point, plastic deformation. It's passing yield. And thus, some of those elements could be an issue. But notice, again, you have kind of a marbled effect. You have internally, you have the dark blue. So what we're seeing here is it is bending, and maybe the exterior surface is undergoing stresses. Kind of like if you were to bend plastic, you might see the plastic turn white on the surface. That might be kind of what you're seeing here. You might not really see anything on the surface of the steel or an aluminum, but maybe a little flaking or possibly of any coating it might have. Anyhow, let's take a look. So the von Mises essentially gives you that information. But if we go to show displacement, this is going to tell us how much it's going to move. So you can see it's in millimeters, and I guess this is scientific notation. So if we're looking at this, it looks as though at the red, that's the furthest point at which it's moving. It's moving about 6.6 millimeters. So there is some flexion undergoing there. Okay, and that pretty much concludes that exercise.